Hello everyone, welcome back to CCNP Routing BGP class Lab 2. So let's look at the diagram and try to understand what's the difference between BGP class Lab 1 and Lab 2. This is Manny, your master Juniper Cisco instructor. Guys, in this diagram we have three routers, router 1 and router 2 and router 3. Router 1 and router 2, it is part of Manny CoreNet AS number, and router 3 by itself it is Othernet AS number 22222. And also, since there is only two routers in the IBGP, for example, in MANIADVANTAGE we have only two BGP routers, we don't have to worry about BGP split horizon issues. And here what I'm saying is I'm asking you to enable eBGP between router 2 fast Ethernet 01 and router 3 loopback 0. So it's not a direct physical neighbor. One side is physical IP address, other side is a loopback address. So we are going to use something called update source loopback 0 on router 3, and we are going to put some special command called eBGP multi-hop. So this is a very good topology, guys, to understand the basics of BGP. So let's go through the conditions. So I strongly advise you to print the diagram as well as draw the diagram or print the diagram and read the condition. So establish eBGP between R2 and R3 using R2 FA01 and R3 loopback 0, and iBGP between R1 and R2. I'm saying iBGP peering, you must be putting a password called the MANIADVANTAGE. So the command is neighbor password, pretty simple. Then like previous lab, I'm asking you to advertise all the loopback except the links. R1 should see all the routes as a best route. So that means what's going to happen here, we have a different kind of a next stop. Whenever R1 advertises to route the R2, R1 will advertise with the next stop of 20.20.20.3. Since it is learning as a eBGP route, when R2 advertises back to R1, R2 will not change the next stop, but R2 will say the next stop is 20.20.20.3. If R1 cannot ping 20.20.20.3 is going to fail. So one of the major solution what ISPs do, they put a special command on R2 saying neighbor R1 next hop self. So guys, remember this next hop issue is totally different from the next hop issue in the BGP Lab 1. In BGP Lab 1, it is a full mesh IBGP. So that one, in the full mesh IBGP scenario, route reflected didn't change the next hop. Here, the problem is whenever route coming from eBGP to IBGP. So this next stop is different. In this next stop, we are going to put a special command. So 1, 2, 3 will be easily achievable. Then we should be able to ping. Then I'm saying after that, we are going to router step number 4 and 5. We are going to play with some attributes. So we are going to see the attributes. So when R2 receive route 333, it should be seeing with a local preference of 150. But when it sees 3333, it should see with a weight of 125. Any other future route, it should be coming with a local preference of 151. So on R2, I'm going to put inbound route map to achieve that one. On R2, I will see both 150 and 125 local preference and weight. But when it goes to R1, R2 will not send weight information, only local preference. So R1 will see the local preference, but R1 will not see the weight. So we are going to see that one. Same way, when we advertise R2 advertises out 2.2.2 is going to advertise with a MED of 111. MED is multi-exit discriminator. Every other route is going to go with a MED of 112. It's not going to do any, we cannot see anything, guys, but we are going to just advertise and we are going to see the metric values. That's what our plan. So this lab is by MANIADVANTAGE. I'm putting condition by condition. R1, R2, then R3, then we are going to see the command, then we are going to do the fixing of next stop issues, then we are going to do the ping, then we are going to play with the local preference. So when I do this number 4 and number 5, I'm going to just come and copy from this information and going to paste it to make sure we get the same information, guys. So let's do this lab. So this is the diagram. This diagram is already I have on my GNS topology. So I want to verify a couple of things, guys. Let's go to router 3. I want to make sure I'm not running any routing protocol. Show IP protocols. If it is nothing, that's good. show IP protocols. There is no routing protocols running. Show IP protocols. There is no routing protocols running. And also I can type show run pipe include IP route to make sure there is no static routing also. So there is no static routing. I'll copy this one just to prove a concept. So if I want to see the next stop reachability, I have configured all the IPs. So from R3, if I do 20.20.20.2, I should be telling it into router 2. And from here, if I do 10.10.10.1, I'm telling it into router 1. So I'm going to come back to my router 3. So if you look again carefully, guys, the loopback wise, it is exactly same as previous lab, but only thing is there's an introduction to new loopback for loopback 1 on router 3. So let's configure router 1, 2, 3 as a normal BGP. We know how to configure. I'm going to move this one up. We know MANICONET is 11111, other net is 22222. So let's keep it like that way and configure it, guys. So config T router BGP 11111. No auto summary, no synchronization, BGP router ID as a good practice. And neighbor wise, there is only one neighbor, 10.10.10.2. Remote AS 1111111, and also network, there are two network, 1110 mask 255.255.255.0. then my next neighbor is going to be 112. So I have these two configured, guys. Let's go to router 2. Router 2 has two neighbor, but remember router 2 is peering with 333. So from router 3, can I ping 3.3.3? So I should have the reachability. So I don't have the reachability. So you have to remember BGP need TCP port 179 as a connectivity. So I have to achieve that connectivity. So what I'm going to do, I'm going to put a static route. So in the industry also they do this one. I'm going to say IP route. If I want to go to 3.3.3, 255, 255, 255, 255, please go to 20.20.20.3. So I had to put a static route to get the reachability, because you have to get the BGP up to generate or to exchange the routing. To make BGP up, we must put a static route. So if I do ping 3.3.3.3, it's working. So it's good now. So router 2, let's configure BGP. Router BGP is belong to MANICONET ASN number. No auto summary, no synchronization. Then BGP router ID 2.2.2.2. Then here, guys, I need one more command. Neighbor 10.10.10.2 password the many, I think it is the many advantage, same as my email and my YouTube account. Okay, so let's go to router 2. Neighbor 10.10.10.1 remote AS 11111. Now I have to type the password. Password the many advantage. If you're not sure, you just copy from the previous lab. So I have done the password. So before I configure the other neighbor, let's advertise the network. I have a network called 2.2.2.0 mask 255.255.255.0. I will do the up arrow. I will change this one to now 22. Guys, we haven't established the other neighbor, so look at this one very carefully. Neighbor 3.3.3.3. Look at the red color here. That's a router 3's address. Remote AS. That other net AS number is 22222. Then I have to say neighbor eBGP multi-hop. So there are 1 to 255 here. 1 is enough, but I'm going to put 2. So that means for eBGP, whenever you are doing at least one side with the BGP loopback peering, you have to have the special command called eBGP multi-hop. So that's it. So I gave this command. So I'll just show you the command syntax. Show run section BGP. So we have BGP route ID network. So look at this neighbor. This is the one of the special command I gave. And on the So this become my local autonomous system number. This also my local autonomous, this is the remote autonomous system number. If they are same, I'm doing IBGP, but this remote autonomous system is 222, so I'm doing EBGP. So let's go to router 3. I want you guys to look very carefully. Config T, router BGP, othernet is 22222. Then neighbor is going to be direct my other physical site 20.20.20.2, remote AS11111. So far good. Here now, if I don't type, now I have typed this one, update source. So by default, it's going to use my FA01, but my neighbor has to get my loopback 0. So update source loopback 0. And also I have to type neighbor EBGP multi-hop. Just see here you have 3 commands. Normally you need 3 commands because R2 using physical interface, that's why we had 2 commands. So, and also guys, right now I had to put there's no password on this one. Then I had to put a network command, network 3.3.3.0 mask 255.255.255.0, the network 3.3.33.0. It's not 33, it is 33.33.33.0 mask. We have to double check. I want to double check the IP, guys. What I'm going to do show IP interface brief, again CCIE trick, include oop. Yeah, that's right, 33.33.33.3. So let's check the entire BGP. Show run section BGP. So be familiarized with all these commands. Why we have a EBGP multi-hop? That means how many routers I should pass to go to that particular interface. Technically 1. If I put 1, that's more than enough. But I put, okay, I just left to default because I didn't type any number. So by default is 255. So you can type either 2 or you can leave it default. Then I'm saying please make my, so on the other side I put neighbor as 333. So this side I'm saying update source loopback 0. So let's see if the BGP neighbor is up right now. Show IP BGP summary. Just see this one, it's not interface IP, I'm neighboring with 333. In this case, what we have to understand is the router ID and neighbor IP both are same. So for example, if I type show IP BGP neighbor, if I look at the router 3 information, neighbor IP also 333. Oh, route ID I did not hard code. That's why it became what 33. So guys, let's check show run. So let's go to R3. We did not follow the, yeah, I did not hard code the route ID. So let's hard code the route ID. Router BGP 22222. BGP router ID 3.3.3.3. So the bad thing is whenever you change the router ID in BGP, just it is a bad behavior. It automatically bring the neighbor down and bring the neighbor up. OSPF, you have to do the clear IP OSPF process, but BGP, the router ID automatically bring up the neighbor. So if I go, so that's very dangerous situation if you are going to do in a real environment. Just see guys, now my neighbor address and route ID is same. So let's analyze the routing table right now. On R2, if I type show IP BGP summary, I have 2 neighbors. One is my EBGP neighbor, other one is my IBGP neighbor, version is 4. This number of received prefixes is 2, that's good. I should have either 0 or a number. If I type without the summary command, I'm going to see the route. Just see everything is the best route, and if you see next stop of 0, I'm generating the route. If I go to R1, if I type show IP BGP, I'm not going to see 333. I'm going to see, but they are not look at the next stop. Next stop is 333. I'm not running any routing protocol. So I like to change this next stop to 10.10.10.2. So let's go through the questions, guys. So my basic BGP is done. So this is my basic BGP. So you can type the commands. Okay, R, if I want to make R1 to see everything as a best route, I have to put a special command on R2. So let's go to R2, config T, router BGP 11111, neighbor 10.10.10.1, command is next hop. So I'll put a question mark. So remember there's only one command right now. The command is next hop self. So let's go to R1 and see if this fixes the issue. Just see, as soon as I type next hop self, like a magic, the 333 has been changed to 10.10.10.2. So that means right now I have the full connectivity. So I want to show you this one too. If I try to ping from router 1, if I try to say ping 3.3.3.3 is not going to work. The reason, the source address is 10.10.10.1, but if I go to R3 and type show IP BGP, I'm not going to see 10.10.10.1. I'm going to see only the loopbacks. So if I try to ping, it should not work. So lots of people do the mistake, why it's not working? Because you are not doing source ping, you are just pinging a normal ping. Whenever you do normal ping, the source address will be interface IP address. So I have to make sure whatever loopback address I'm having on R1, which is advertised, for example, show IP interface brief include OOP. So I can ping from any of these loopbacks. I can say ping 3.3.3.3 source loopback 0, or I can type source loopback 1. But if I type without the source, it will not work. So guys, we'll go through this, the flow we want to just go through. Okay, so I think this is the next one, 4 and 5. We are going to play with the, so right now if I type show IP BGP on router 1, so we are going to check the prefixes 3, 33, 2. Okay, so those are the prefixes. On router 3, if I type show IP BGP, I'm on show IP BGP. This is the default metric, default weight, default. So we are going to play weight, local preference, and metric. So most of the commands are going to be on R2. So as per my goal, when I receive 333, I should have a local preference of 150. When I receive 33, I should see weight of 151. Anything else in the future should be weight of 151, but I should not see, so I will be seeing local preference, that means 333 with a local preference of 150 on R1, but weight will not go. So let's see if I can copy and paste this one, guys. Copy. In a big exam, you have to use notepad document. So these are the things I'm going to type. So route map is a condition. So in the route map, so the best thing is I can type exit. I'm just making sure like you guys see and understand the concept as I'm doing right now. So 10, 20, 30, they are called sequence numbers. So the route map name is from R3. I'm putting everything is permit. So access match IP address. Okay, match IP address 3. It should be match IP address 33 because that's the access list number. Local preference of 150. And also the next one is going to be match IP address prefix list net 2. So you can pause and you can write down these commands, guys. These are the correct commands. Set weight of 151. So the way I did to define okay, so I think whatever, so let's copy back one more time. I'm going to do from R3. I think we have to type. Okay, so we have to define three things. So what I'm doing here, access list 3 permit 3.3.3.0 So we have three definition. One is access list 33, access list 3, and this is I'm using for different purpose. So in this one I am saying if it is matching IP address 3, so match access list 3, my local preference is 150, that's right. If it is matching my access list number 33, my weight is 150, weight is 125, it should be 125. Okay, so look at the conditions very carefully. Weight should be 125 for 33. Anything else, my local preference should be 151. So this is good. Okay, so I'm going to type this one, guys. So you can take a pause, copy, I'll go to router 2, paste. So it took the route maps and everything. So now I have to go back to my PDF document here. So let's configure this one too. So that means this is outbound to R3, and also we are going to apply to the neighbor. So let's do that one. So copy, because when you copy and paste from PDF document, it might not work as you expected. That's what happened before. Okay, so far good. Okay guys, so that's good. So here we already defined what is net2. So let's put these commands on router 2, exit. Okay, so commands are big. So let's type the command show run begin router BGP. Take a moment, pause it, analyze. So router 2 command wise, router 3 has a route map called from R3 and in and to R3 out, and we have defined 3 network. One is prefix list called net. I have already net2, and also I have a PL net2, but I'm using this one only. That's from the previous lab. So from R3 has 3 sequence number 10, 20, 30. If it is matching access list number 3, local preference is 150. If it is matching access list 33, weight is 125. If it is matching anything else, local preference is 151. Outbound direction, I am saying if it is matching net3 prefix list, metric is 111, metric is med, and also anything else, metric is 222. So that's the commands, guys. Again, take some time, pause it, just see what was done. So let's go and verify whatever we did. Okay, so whenever I do a change on any router, I'm going to type the command clear IP BGP star soft. So that means this is soft in and out. Okay, so if I type show IP BGP, even before I look, if everything is good, 333 should be coming with a local preference of 150, and 3333 should be coming with a weight of 125. Let's check. Just see, 333 is coming with a local preference of 150, but 3333 is coming with a local preference of 125. Other ones I did not say anything, because we are only getting 2 routes from router 3. If I go to router 1, I will see this 150, but I will not see this 125, because local preference is within the autonomous system, but weight is local to the router. So that's the concept. So let's try the same command, show IP BGP. As I said, we will see the weight, we will see the local preference, but we will not see the weight. Just see, I'm seeing the local preference, but I'm not seeing the weight for this 33. Now, how you know the other side is good? If I go to router 3, I should see 222 with a metric of 111, everything else with a metric of, so whatever we typed, 111 and 222. Show IP BGP. You see, guys, the local ones are metric of 0. Apart from that, 222 is metric of 111. Both are metric of, so metric means med, multi-exit discriminator. Guys, this lab is not to give you like kind of how to do the route manipulation, but just understanding the ability of behind the technicality behind the path attributes. So I think that's the lab is almost done. Let's go back and check the configuration, some commands, then we will wind up this lab, guys. So I'm going to go from the beginning, router 1, router 2, router 3. So router 1, show run section BGP. There is nothing much. Router 3, show run section BGP. And also I can type show IP BGP summary. And also I can type show IP BGP. I can see the BGP table. On this one, router 1, I can do the same thing, show IP BGP summary, then show IP BGP. Router 2, which is having, so I'm going to put additional command. First of all, show IP BGP summary. Then we are going to see a command, show IP BGP. You will see whatever you're going to see you're going to see the BGP table, and here I'm going to put one more command, guys, that's called show IP BGP, show IP route BGP. You are seeing 20 is nothing but routes are coming from eBGP, and 200 is nothing but routes are coming from iBGP. So this is a perfect example of seeing both the eBGP route and iBGP route. And finally, I want to show you one more command. Show IP BGP neighbor. So this is a very long output, but still worth it. Look at this one, guys. One of the neighbor is 333. The route ID also 333. It is external link. External link means it is eBGP. If I go down further, if I want to see the next neighbor, my next neighbor IP address is 10.10.10.1. The route ID is 1111, but it's an internal link. So internal link is iBGP, external link is eBGP. Guys, so again, the major commands are on router 2. I'll just put that one more time. And good luck in your studies. So make sure to do the CCNP Bgp class lab 2 a couple of times. Do the labs, read the concepts. This is Manny, your Cisco-Juniper Master Expert Instructor. Good luck again, and thanks for watching this video. See you guys.